Okay, so question 8 from Check Your Skills in Exercise 5.10 asks you, it says, given sine 70 degrees, which is equal to t, and without using a calculator, express each of the following in terms of t. We've been given sine 110 degrees, a negative 110 degrees. We're given cos 140 degrees, and we've been given tan 70 degrees. So, in terms of t. Now, sine 70, we need to understand that it exists within a Cartesian coordinate, okay? And if we are to draw a Cartesian coordinate, it ends up being up here, our 70 degrees, right? And it is equal to t. We know that sine's ratio is the same as y over r. Therefore, this is t over 1. So if we are to draw this out, t ends up being our y value. We're not sure what our x value is, but we know that our unit measurement here is 1, which is our r. Therefore, to find out what x is, we need to apply Pythagoras. So we're going to go x squared is equal to r squared minus y squared. And r is 1 squared minus y is t squared, which simplifies down to x equaling the square root of 1 minus t squared. The square on the 1 falls away just because 1 squared is 1 squared. So x is equal to 1 minus t squared, all square rooted. I cannot square them independently because they are joined together by that minus. It's one term. Okay. We normally do this. This is a grade 11 way of dealing with these sums, that we can identify sines, coses, and tans in this ratio. But what we're going to do is we need to write everything in terms of t, and we need to try to change sine a negative 110 degrees into a positive 70 degrees. So what laws can I apply to this 110 degrees? Do I apply reduction laws? Do I apply cofunction laws? Think about it before I actually start. So this ends up being your negative angle. We know that the negative angles go around this way, the minus way, right? Minus thetas. So I could rewrite this as sine minus 180 degrees. If I add 70 to it, that would take me to negative 110, right? So when I've got a negative angle of plus 70, think about it. We're going around minus 180, adding 70, we end up in this quadrant. So we end up getting it a negative sine 70 degrees, which simply just makes me have a negative t, because I've got sine 70 is equal to t, minus sine 70 is going to be minus t. Again, guys, just look at this identity here. We ended up having minus 180 degrees, which takes me from there to there. So that takes me to minus 180. I need to add 70 degrees, which puts me in this quadrant over here. And this is my tan quadrant. So I've got a negative sign in this quadrant. Okay, cos 140. Well, we can see that cos 140 is the same as writing cos 2 times 70. And we've got a sine ratio, which is the same as looking at our cos double angle. So we then change it to our sine ratio, which ends up becoming 1 minus 2 sine squared 70 degrees. And if sine 70 is equal to t, then 1 minus 2t squared must equal to 1 minus 2 sine squared 70. Here we end up having tan 70. We know that tan is the same as writing sine 70 degrees over cos 70 degrees. It's another ratio that we end up having. And we know that according to our trig ratios, we end up having sine, which is y over r, over x, which is x over r, right? And we know what that ratio is. We did it according to this Pythagoras. We also know that tan is y over x, which is the simplified version of these two. So we can automatically put in to our expression over here our y value, which is t, over our x value, which is 1 minus t squared. And it's the square root of that. So there you have your three different ways. This one we used the negative angle reduction formula. This one we used our double angles. And this one we went straight into using our triangle. We didn't actually have to go do this step. You could do that step, it's not a problem. You do have to, you can't just write that. You have to show me some working out so that you can get the marks. But we would accept that that is your valid answer, and a valid answer.